Hi, Mr. Pepperell here. I'm in the greenhouse thinking about choosing a fuse. Hopefully by the end of this video we should be able to calculate the correct current for a fuse and we should know which fuse to choose.
So, previously we've discussed how a fuse works to protect a device when an excess current flows through it. And if you remember, the little bit of wire through the middle there, when too much current flows, the resistance causes it to get hot and the fuse melt or blows. Okay, we also found out that fuses can come in a variety of ratings. We've got a 3 amp fuse, a 5 amp fuse and a 13 amp fuse there. Okay, so how do we know which one of these fuses to actually choose? Well, what we do is we look at the relationship between power, current and potential difference, and it's all linked up in this equation. You'll remember power supplied is equal to current times potential difference, which we can actually abbreviate to P equals I multiplied by V. So if I know the power of an appliance and I know the potential difference across it, I can easily rearrange that equation to calculate the current that's going to flow through it. So I'm trying to work out the current, so as always with this, I cover up the one that I'm trying to work out, and I can see that if I know the power of the appliance and the potential difference across it, I'll be able to work out the current flowing through it. So let's just try a little example of that. I'm looking at a 750 watt heater in the UK. Why is it relevant what country I'm in? Well, of course we know that UK peak voltage is 230 volts. So I've got the two values I need there. I've got a power, 750 watts, I've got a voltage, 230 watts. Okay, I can easily substitute those figures into my equation, so I can see here that current is equal to the power of 750 divided by the potential difference of 230 volts, which gives me a current of 3.3 amps. So now I know the current through the device. How do I know which fuse to choose? So we know my appliance needs 3.3 amps of current to work, but which rating of fuse should I pick for that? Well, the value closest to my result is 3 amps, so I've got a 3 amp fuse there. But if I let 3.3 amps of current flow through a 3 amp fuse, all that's going to happen is my fuse is going to blow. Okay, so in the case of an appliance which requires 3.3 amps of current, what I'm going to do is I am going to pick a 5 amp fuse. Now, although that rating is slightly higher than the current flowing, a 5 amp fuse is going to blow before any real damage can be done to the machine should the current start to increase. So now you try one. Okay, so here's my question. Which type of fuse, a 3 amp, 5 amp or 13 amp, would I need for a 12 volt 24 watt heater? Okay, so pause this now, try the problem and then hit play for the solution. Right, hopefully you have paused it and you're not just copying this down. So how do I go about solving this problem? Well, the first thing I do is rearrange my P equals IV formula, to arrange it for I, and that is going to give me I equals P over V. Then all I do is I substitute in my values, so I need a power value, I got it there, 24 watts, and I need a voltage, 12 volts, got those two. Okay, I just substitute those two values in. 24 divided by 12 is going to say 2 amps is my answer. So which fuse am I going to choose for the heater? I'm going to choose a 3 amp fuse because that is the closest rating of fuse that is the sort of next highest level for that one. Okay?
So hopefully now you know a little bit more about choosing the correct fuse for an appliance. Any problems with that, don't hesitate to tweet me at Mr_Pepperell or email me and I'll get back to you ASAP. Thanks for stopping by.